What is an ERC20 token? Before we get started, let's define what an ERC20 even is, or rather, what a token is on an Ethereum blockchain. A token can represent currency, shares, loyalty points, certificates, etc., etc. When you want to create your own token, you have to write a smart contract and deploy it to the blockchain. But as we know, doing so is very risky because once you deploy it, you cannot change it. Your token may not be interoperable with another token on the blockchain, or the exchanges may not even be able to list your token for trading because it's an enormous task to be able to support thousands of different tokens on the platform. That's where ERC20 comes into play. ERC20, for short, actually stands for Ethereum Request for Comment. It's a guideline that defines 6 mandatory functions and 3 optional functions that your smart contract must implement. This standard lets you have a name for your token, symbol for your token, and a number of decimals to have which can be divisible when transferring fractions of your token to other people. The 6 mandatory functions are total supply, balanceOf, transfer, transfer from, approve, allowance, and the 3 optional functions are name, symbol, and decimals. You can create an ERC20 token in different ways. One of the easiest ways is to use a service like the one provided by smartcontract.tools. Here you can see here on the web page here. We're going to go to create ERC20 on Ethereum. Then we're going to give some details here. So I'm going to put in my example token, MET for the token symbol. I'm going to have 10,000 initial supply. Here I'm going to choose simple ERC20 so we don't have to do a whole lot of customization here. But you could also choose some other options here, like if you choose a standard ERC20, you can put your own decimals here. I'm not going to be doing that, so let me go back to simple ERC20. Here you can choose Ethereum mainnet or whatever testnet you want to deploy to. I'm going to choose Remix.IDE testnet and then hit next. This is a test network we're deploying to, so we don't really need to put in the billing information from this website, so we can skip this step. For the mainnet, if you were doing it, you will need some real Ethereum, so to be real Ether to be able to deploy this contract. But anyways, getting back to this, so the next thing to do is to basically make sure everything is correct and then create token. Now it's going to ask me to confirm, so I'm going to confirm here, and there's the transaction hash. So it looks like it is pending right now. After this is created, it's basically going to be live on Remix.IDE testnet here with the complete supply of 10,000 METs and the smart contract address. So let me just go over here, and you'll see here that I can choose. So if I were to go to my address, you can see here this is the total number of total supply. This is the smart contract address. This is the decimal place we initialized here, and that's about the only thing you need to do. So this didn't involve you writing code at all. So that's one of the good things about this. Second way is to implement the methods to the ERC20 interface yourself, which you will have to use something like Remix, or you can even code it yourself on VS Code or something like that, where you're gonna need to implement the methods to the ERC20 token interface yourself. This has some downsides, as you would need to implement all the logic yourself, but you also have more control if you want to customize it to your own liking. Third way is to integrate OpenZeppelin library onto your own smart contract, then create the ERC20 tokens. The majority of the legwork would be done because your implementations of the ERC20 standard is already done through the OpenZeppelin library, and it has some reusable components that you can use to build custom contracts in complex, decentralized systems. But most of all, these libraries are audited by leading security firms, so you don't have to do a whole lot of that yourself. You can see here on the documentation of OpenZeppelin, you can you have access to various of these components here you can utilize into your own smart contract. We're going to be diving deep into how to create, how we're going to be inheriting ERC20 here. This implements the ERC20 interface. So this way, all of these functions here are automatically available to us without us having to code anything. That's the main difference between writing your own smart contract, which in that case, you would have to implement their own logic to total supply, balanceOf, transfer, all of these yourself. But if you were to use OpenZeppelin library, you don't have to do any of that. So that's the main advantage of using that. Let's move on to the tutorial. First, we're going to remix.ethereum.org, where we can write our smart contracts. We're going to write an ERC20 smart contract in 2 ways, and we're going to implement the exact same functionality in both the smart contracts. One by implementing on the logic ourselves, as described by the second method, and another one by integrating OpenZeppelin library onto our smart contract, as described by the third method. First, we define pragma at the top, which says which Solidity version to use. Then we define all the public and private variables we need to keep track of, such as the admin, which has extra control over certain functions, like when trying to mint more tokens, name of the token, which is going to be my example token, symbol of the token, which is MET, total supply of the token, which is 10,000 METs. We're also defining the number of decimals to be 18, as determined by the value assigned in the total supply variable. Then we move on to define two events: transfer, which is emitted on each transfer of the MET tokens, and approval event, which is emitted when the user approves the spending of their tokens by a third party. The last two variables are balances, which keeps track of all the users who own the MET tokens and how many METs that they each have at any point in time, and the variable allowances that keep track of all the approvals someone has done, which determines how many of their MET tokens can the approved third party can spend on their behalf. Now, let's move on to the constructor, where we define who is the admin. This is basically someone who deploys the contract to the blockchain. And we also initialize the initial deployer, which is the admin, to have access to all 10,000 METs tokens in the beginning. Next, we move to the function transfer that moves the MET tokens from the caller's account to the recipient's account. We return true or false depending on whether the transfer was successful. We implement the transfer from function that moves the MET tokens from the one account to another account, whereby the caller or the spender is actually a third party that the user had previously given approval to with the approve function. Third function is approve, which we just described, which does exactly that. It authorizes a third party to spend a certain amount of tokens in the future. This is the main difference between the functions transfer and transfer from, whereby transfer moves tokens directly without any approval, as the person who is sending is the owner of the account, whereas transfer from moves tokens whereby the person who is sending is actually not the owner of the account, but rather it's a third party. Fourth function we're going to take a look at is allowance, which returns the remaining number of tokens that the spender will be allowed to spend on behalf of the owner in the future. Fifth function, balanceOf, returns the amount of MET tokens owned by the account. Sixth function, the last mandatory function, is the total supply function that just returns the total number of MET tokens in existence. We can also implement the three optional functions, name, symbol, and decimals, which are pretty self-explanatory. Now let's implement a second smart contract, but this time using the OpenZeppelin library to do the exact same thing we did just now. We import the OpenZeppelin library, then we inherit the contract ERC20, and then define the admin variable that will have access to certain functions like before. Then we write our constructor by inheriting the ERC20 with the name of the token, my example token, and the symbol MET as before. As part of the constructor, we're going to mint the total supply of the MET token by setting it to 10,000 METs with 18 decimal places again. And we're going to set the deployer of the contract to be the admin, just like before in the first contract. And that's it. We're done. As you can see, it's quite easy to implement an ERC20 token contract using OpenZeppelin library because majority of the legwork is done for us. As a bonus, let's implement the function where we can generate new MET tokens and add it to the total supply, and then burn function to get rid of some MET tokens from the caller's account forever, which will reduce the total supply. Basically, mint and burn functions. We can now implement these two functions on our second smart contract with OpenZeppelin. And the way to do that is to just call the _mint and _burn function that is part of the ERC20 contract we inherited in this contract. Well, that's about it. I hope you learned today what an ERC20 standard is, how to write your own ERC20 token from scratch, and how to write it using OpenZeppelin library. Now, what we're going to do is we're going to deploy these two contracts and play around them with a little bit. First, let's deploy example token regular.sol on Remix. We can check the admin, who is basically the deployer. We can check the name, symbol, total supply, decimals easily because they're publicly available functions now because we implemented them. Now let's send some MET tokens to another account using the transfer function. That should work. Let's do the same thing using transfer from function, which will fail because, as you know, we first need to have the second account approve the first account using the approve method. So let's do that now. Let's approve it. After the approval process, we can now send the tokens using the transfer from function. And that's how, that's basically the difference between transfer and transfer from function. We can also mint two tokens. We can mint new tokens with the admin account with the mint function. And we can burn some tokens with our second account, which does not need to be an admin because, anyone should be able to burn the token no matter what. And that's about it. So that's how you can deploy it pretty easily. I hope this was helpful. Thank you.